trigonometric identities. We've accumulated a few. An identity is just an equation, basically. So some identities we've accumulated so far, we have discovered that the tangent of any angle is always equal to the cosine of the angle divided by the sine. Ooh, got that upside down. Sine over cosine. Sine of the angle over the cosine of the angle. Doesn't matter what the angle is. That relationship is always going to be true. So we can just make up any angle, test that out. So I'm just going to go to my calculator. And I'm going to switch to Desmos. Let's use the scientific. I'm going to switch, it's in degree mode, we'll stay there. So if I take the tangent and then I pick an angle like, let's see, 51. The tangent of 51 is 1.234897, blah, blah, blah. According to the identity, that should be the same as the cosine of that angle, 51, close parentheses, divided by, I keep doing that backwards. What is your problem, Gary? The sine of the angle, there we go, 51, divided by the cosine. 51, got to be the same angle. And computer says, yeah, they match. Doesn't matter which angle you pick. You change that 51 to something else, like 73. And you change these two angles to 73. That's going to match. Oops, 73, right? Same answer. Identity is just an equation. So that's one of our identities. Another identity we have is we learned that the secant of theta is equal to 1 over the cosine. Doesn't matter what angle we pick. So if you need to do something with a secant, but your calculator doesn't have the secant button on it, then you can just use 1 over cosine instead. Let's do cosecant next. Cosecant of theta is 1 over the sine of theta. And the cotangent of theta, oh, now I get to write cosine on top, to the 1, 2 for a while apparently, is cosine over sine for a given angle. All right, so these are some very important basic identities. They're kind of our definitions to go by. Highly recommend you have those for memorized. Some other identities related to the Pythagorean theorem. So we know that the sine squared of an angle plus the cosine squared of an angle is equal to 1. We learned that, let's see, another one, the tangent squared of an angle plus 1 is equal to the secant squared. And I drew a picture to show that in a previous video. So if I have this crazy square identity for sine and cosine and tangent and secant, I wonder, is there one for cosecant and cotangent? And it turns out there is, and I'll show an algebraic instead of a geometric way to do it. I did draw a picture earlier that kind of showed, but I didn't do it right here. We could apply the Pythagorean theorem to this triangle right here and come up with it. So feel free to check that out on your own if you wish. I'm going to do a slightly different bit of jiggery-pokery here. Okay, so let me see. I want something with the cotangent in it. Cotangent has sine in the bottom. So somehow I want to take this sucker and get a sine in the bottom. So here's what I'm going to do on that. Just a little bit of mathematical magic. I'm going to start off with sine squared of theta plus cosine squared of theta equals 1, right? This one right here. But then I'm going to tweak it by dividing each part by the same number, and that number is going to be the sine squared of theta. And I'm going to clean it up. So one thing we're going to learn to do in this class is manipulate these identities in different ways. Okay, well, sine squared divided by sine squared, that's a number divided by itself, and a number divided by itself is 1. That's cool. Cosine squared divided by sine squared, well, I can rewrite that as the cosine of theta over the sine of theta, all squared. And you might say, why would you do that? Well, because I know that cosine over sine is the cotangent. So that means inside the parentheses here, I can rewrite the cotangent instead, squared. And then here, 1 over the sine squared, that's kind of like 1 over the sine. So 1 over the sine squared should be the cosecant squared. And you got to have an angle there. And there's 2 ways to square a function like this. You could put parentheses and the square on the outside. And there's a shorthand notation you'll see more often where we write it just above the last letter for the square. So if you see something like cotangent squared of the angle, order of operations is first you find the cotangent of the angle and then you square the result. We're not squaring the angle, we're squaring the function. Oops, that should be equals cosecant squared of theta. So we have another trigonometric identity. So it turns out there are 3 Pythagorean trigonometric identities. This is the most important one. You definitely need to know that. Optional, right? So this is superstar. And then optional things to know is this version of the Pythagorean theorem and this version of the Pythagorean theorem. But by far, this guy right here is the superstar. Okay. So like what's a famous, if these guys were actors, this is like one of the most famous actors in the world. Who would that be? I don't know. I haven't watched many movies lately. I'm afraid to go to the theater. I guess I've watched a lot on Amazon. Who's someone famous? Help me out here. Who's the guy that plays Thor? He's kind of famous. What's his name again? Damn, I can't remember. Oh, well, it's famous. We'll just go with that. All right.